Hello, in this video we will examine how students can use the spreadsheet tool on ClassWiz to explore the Fibonacci sequence. The Fibonacci sequence is very famous and examines the sequence of numbers starting with 1 and 1, and in which every term after that is the sum of the previous two terms. So 1 and 1 make 2, 1 and 2 make 3, 2 and 3 make 5, and so on. Our ClassWiz is turned on. Let's set it up. We'll be using spreadsheet mode in this video. So tap the menu and spreadsheet mode, you can see from the icon over here, is number 8. So we can just tap number 8. The spreadsheet is a powerful tool for exploring many kinds of mathematics. The spreadsheet on ClassWiz has 5 columns and 45 rows. We're going to start by generating the Fibonacci sequence in column A. This one here. So we'll put the first two terms into A1 and A2. My cursor is in A1. I'll just type 1 and equals. Notice it moves down automatically. And 1 in A2 and equals. The next term is the sum of the preceding two terms. So we can get the spreadsheet to use a formula to calculate it for us. Formulas always start with an equal sign, which is obtained with the alpha button and the calc button. You can see the equals down here, not the equal sign at the bottom of the keyboard. Then we insert the addresses of the terms to be added, in this case A1 and A2. So we do alpha and A1, add alpha A2. After the formula is entered, we'll just tap equals, and notice that the formula has added 1 and 1 there to get 2. Before studying Fibonacci, we'll first see two ways of controlling the spreadsheet with two important settings. I'll move the cursor back to A3, and you can see that the cell shows 2, and at the bottom of the screen the sum of A1 add A2 is shown, the formula is shown. You can show the value at the bottom of the screen instead of the formula by changing a setting. To see the setting, tap Shift and Setup. Go down to Spreadsheet number 4 to access the spreadsheet settings, and we're going to use Show Cell, which shows what is showing in the cell. If we choose Value instead of Formula, the formula will be hidden. But importantly, the value will be shown. So let's do that. Tap number 2, and now you can see at the bottom of the screen it doesn't show the formula, but it shows the value that's in that particular cell, or indeed in other cells. Let's go back and change it to show formula for now. Spreadsheet, and I'm going to change it back to show formula because that's what we'll use for the moment. Now let's move the cursor up to A1 and we'll change the value to 7. And watch what happens. As soon as I press equals and change that to 7, the spreadsheet has automatically calculated 8 in A3 because it's the sum of A1 and A2. So the spreadsheet automatically calculates results of that kind, which is a critical advantage of spreadsheets. But we don't always want to do that. So let's go back and see how we can change that setting. Shift and Setup, down to the spreadsheet setting again with number 4, and the Auto Calc can be selected, number 1, it can be on or off. So for now, turn it off with number 2. Let's see what happens if we now go back to A1 and we change it back to 1 as it was previously. Notice that A3 doesn't change. It still has the previous value. The formula says A1 add A2, but the result is not correct because it is not calculated automatically. We can calculate it manually in the following way. We can go Option and down, and number 4 is Recalculate. So let's do that, Recalculate, And now notice that the value is correct. It's been recalculated manually. So those two settings are important, but let's again now go back and change the auto setting, the spreadsheets, the auto calc. Let's put it back to on, which is number 1. Okay, now back to thinking about the Fibonacci sequence. You could put a formula like the one in A3 in each of the cells A4, A5, A6 and so on. But that will take a long time. The spreadsheet allows you to do that automatically using a fill formula. So let's go back and highlight A3, and we're going to, instead of the formula that's there at the moment, we're going to insert a fill formula. So option and choice number 1 is a fill formula. Notice the equal sign is already in place, and we're going to say the same formula, A1, add A2. It's the same as before, only now it's called a fill formula. And I'll tap equals, and we can check that that's correct. But the range we want to use is not just for cell A3 now, but it's for lots of cells. So let's go here and change this A3 to do it for a range of cells. So let's change it to make it the entire column to A45 and tap. As soon as we tap equals, the entire spreadsheet will be changed. We just check that it's correct, A3 to A45, and then tap equals, and we can see here the spreadsheet has inserted a formula into A3 as before, but it's also inserted a formula in every other cell, as you can see as I'm scrolling down. So the spreadsheet has interpreted the formula as doing the same thing for every cell as it did for A3. Add the previous 2 results. So in A18 it's added A16 and A17 and so on. This idea is called relative addressing, and column A now contains the first 45 terms of the Fibonacci sequence, and you can see they get to be very large. We can also scroll upwards, which is often the quickest way of getting to the bottom, particularly if you start at the top. You can see here, there's the bottom, and you can see very large terms. The formula down here shows how they were calculated, but the cells are too small to contain the actual values. So this is not very helpful. So now we go to change the show cell setting to value, as we did before. Shift and setup, down to the spreadsheet settings, number 4, and we'll change show cell to show now the value, number 2, and not the formula. And now we can see on the bottom of the screen here the actual values. And this is a very large value. The 45th term, as you can see, is more than 1 billion. Although it just seems that it starts off with very small numbers, it quite quickly becomes very large. And likewise, all of the others now show the values. So a spreadsheet is a powerful device for exploring mathematics. To see an example of this, let's go back here and change A1 from 1 and make it 5 instead of 1. And tap equals. And notice everything has changed. The spreadsheet has said 5 and 1 make 6, 1 and 6 make 7, 6 and 7 make 13, 7 and 13 make 20, all the way down. And we can have a quick look at number 45, is now almost 3 billion, a very, very large number with a very small change. So let's go back again and change our A1 back to 1, so it will automatically recalculate and everything will be as it was before. We can just check there that that's as it was before. And now let's try a different change and change A2 to 5. So now we have 1 and 5 as the first 2 terms. And you might think this is the same as starting with 5 and 1, but in fact it isn't. The terms are all different. And now if we have a look at the 45th term at the bottom, you can see now it's almost 4 billion. So we get quite different results, but we can study them easily using the spreadsheet tool. Let's change it now back to 1 and make it the original Fibonacci sequence. Don't change any of the cells in A3 down to A45 because they've got formulas in them, and that will be a serious problem. Now let's look at another critical spreadsheet capability called absolute addressing. What we've been using with this formula is relative addressing. To see how this works, go across to D1 and we're going to put 1 in D1 and 1 in D2. And we're going to use those values to control the starting numbers, A1 and A2. So let's go back now to A1. Instead of putting 1 in there, instead of putting a number in there, we're going to put a formula. And the formula starts with an equal sign, as all formulas must do. And we're going to tell the spreadsheet to use whatever value is in D1, exactly in D1. And to do that, tap Option, and we need to use a $sign, number 1, which is a standard spreadsheet way of describing absolute addressing, alpha D, and then another $sign, and 1. So this is telling the spreadsheet to put in A1 exactly what is in D1. And of course nothing seems to change. Absolute addressing can be used for other purposes too. For example, let's put in cell D3 a formula to read what the value in A45 is. So we have an equal sign to start the formula. We have an absolute address, and we're going to this time look in A45 to save having to go and check each time. And we want a $sign again, and it's 45. And so now you can see that the result of A45 is automatically in cell D3 without having to scroll and look. And if we make a change, for example, to the first term of the sequence, make that a 5, notice that the value in D3 changes in the way that we saw before. And if that was a 1 but we changed this second term to a 5, notice the value at A45 has also changed as before. And the Fibonacci sequence, of course, over here has changed in the same way. So I'll change that back now to where it was. The Fibonacci sequence has many amazing properties which have delighted and surprised many mathematicians of all ages. To see just one property, let's use our spreadsheet to compare each term of the sequence with the previous term by dividing. Firstly, we'll change our show cell back to show the formula so we can see how this is working. So go down on the setup menu down to spreadsheet and show cell, and we'll change it to formula so that the formula is showing. And now let's over here go to B2. We're going to insert a fill formula to do all of the divisions efficiently. We're going to divide each term by the one before it. So the fill formula, we do Option and Fill Formula in B2. The formula is to divide the value in A2 divided by the value in A1, which is the previous one. And tap equals, we check that the formula is what we intended. Then we can edit this again. And we want to go from B2 right down to the bottom of the column, B45. And again, we can check that. And just to remind you, A2 divided by A1 divides one term by the previous term, and this is going to record the results in column B. As soon as we tap the equals key, all the calculations are completed. And let's just check the first few of those. It's always a good idea, always wise, to check the first few of a formula just to make sure that it's working. So 1 is A2 divided by A1, as the formula suggests. 2, A3 divided by A2. Notice the formula down the bottom here because the show cell uses the formula. The next one down, 3 divided by 2 is 1.5. Check one more, 5 divided by 3 is 1.666. So the formula seems to be working okay. And now we can use the spreadsheet to see what happened. What happens to these results when you get the ratios? And if we scroll down a bit, we can see something strange. They seem to be getting close to the same value. And in fact, they're always 1.618 after about the 14th or 15th term. But maybe that's because we only see 3 decimal places. So let's now show, instead of the formulas down here, we'll go back to show cell and show the value. So shift and set up again, familiar path down to spreadsheet, show cell, instead of the formula, now we'll have the value. And we can see, they're not really the same. This one is 1.618037. The next one is a little bit different. The next one's a little bit different. So they seem to be the same to 3 decimal places, but they're not quite the same. So let's scroll down a bit further. And now they are the same, it seems. This is not changing. Every cell seems to have the same value, which is a very mysterious process. And people are quite surprised to find that this ratio doesn't change, at least to the first 9 decimal places that ClassWiz is able to provide. So after the first few terms, the ratio of successive terms is a constant, or at least so it seems. Let's now move back to cell D3. And to avoid having to scroll down all the time, let's go over here and we will edit the command in cell D3. Option, edit the cell, number 3. And you can see the formula. Remember, the formula was to find the ratio. The original formula was to find the bottom of A45. Let's go down instead now to change it to make it the bottom of the B column. So it will show us what that ratio is instead. And tap equals. And it seems to be the same. So this value of 1.61803, etc., is a very famous mathematical value called the golden ratio, has excited and delighted mathematicians of all ages for many years. And we now don't have to be scrolling around. Finally, let's look at a rather amazing property, that if we now change the sequence, not in that way, but change the sequence by changing the starting values like we did before. The Fibonacci sequence is full of surprises. Let's change this 1 to a 5 and watch what happens. The results over here in column B are all different. 1 divided by 5 is 2, 6 divided by 1 is 6, and so on. And what happens eventually at the bottom of the table, we can see over here, is the same as before, which is very mysterious. And if we, instead of having 1 there, we change this one to 5, the end result is the same. And if we change this one to something different, like starting with a 7 instead of a 1, it still ends up at the same value. This is a very deep mathematical result, and the spreadsheet allows students to see this. Many surprises are available with the Fibonacci sequence, and this is just one of them. Well, that's the end of our adventures with spreadsheets and the Fibonacci sequence. Students can use spreadsheets for many other purposes, of course, not just this one. You'll find Module 13 of the ClassWiz book also contains information on how spreadsheets work on ClassWiz and how they can be used to explore a variety of mathematical topics, as well as detailed explanatory text which can be copied for students as well as teachers. The module includes some exercises to check the efficient ClassWiz use, some examples of activities to suggest educationally valuable things to do, and some guidance for teachers. You can download this book freely from the Casio Worldwide Education website. Happy calculating!